So to recap, one of the main topics of our last session, we were reviewing the difference between the term service data unit. This is also known as a payload, or it's the contents of a digital package, right? And or a digital bundle. So whenever you have ones and zeros in motion, they're configured in different ways depending on the layer where they're used, where they're processed, and each layer essentially unloads payload after payload after payload. So each chunk of digital information at each layer has a specific name. That's called, if you take the entire chunk of data, it's called the protocol data unit. So there are PDUs on each layer. There are PDUs on each layer of the OSI model, and the PDU is called a frame on layer 2, a packet on layer 3, and a datagram from layer 4 on up. So each of the headers of those digital packages, right, those chunks of digital information, have essential information in the header, kind of like the outside of the box has essential information about who's sending the box and who's receiving the box, right? So it's like the address part of an envelope or a package you'd get from the US Postal Service. The CRC is often, that stands for cyclic redundancy check. Another term for that is checksum. It functions like a packing list. So when something is unloaded from the SDU, right? So when you remove the SDU, the service data unit on layer 2, what's inside is a layer 3 packet, complete with IP address to and from. And we verify that the entire packet was received properly by checking it against the packing list, better known as checksum, better known as cyclic redundancy check, or CRC. These are things that are performed by algorithms at every step of the layer. Are there any questions you can think of related to the information we presented late Friday and this morning? Okay. One of the things that we wanted everyone to understand is that this entire process is referred to as encapsulation. So in the higher layers there of the networking model, OSI model or internet model, the datagram is encapsulated inside a larger datagram at layer 4, which is encapsulated inside a packet on layer 3, which in turn is encapsulated in a frame on layer 2. Now, layer 2 operates on the local area network, and it is the MAC address that is the most prominent and most, well, it's most essential to get the process started on layer 2 when somebody connects. Now, to get into that piece of the process, when your machine connects to a Wi-Fi network and it receives an IP address for use in the layer 3 packets that are being sent and received to and from your system, that IP network address assignment is not just a random number that's picked out of thin air. In smaller networks, that can becomes catastrophic, especially if more than one device has the same IP address. So the physical identity of the interface, called the MAC address on layer 2, is involved in a broadcast, an initial broadcast, where as you're starting to connect to a network, it says, hey, I'm here and I need an address. and there is a service, a special service, that automatically assigns unique, never to be duplicated IP addresses to a connected device. The other thing that's important to understand about MAC addresses is that it's essential for connectivity with other types of network transmissions. So not just IP networks on the internet, but also things like infrared and Bluetooth, which also is transmitted and received on the 2.4 gigahertz frequency. So it's like microwaves. Yeah, it is a microwave. Yeah. So Bluetooth is microwave energy. Let's repeat that. When you're using a Bluetooth device, there is microwave energy associated, small amounts, with that device. And there's been a lot of conspiracy theories circulating the internet about what happens to body tissue when people use Bluetooth devices, or they use Wi-Fi and they're always carrying them in the same place. As a health and safety habit, I always carry like my smartphone, which is IP enabled and Bluetooth enabled. I switch pockets once a month. I carry it in a holster on a clip on different hips every other month. And I just do that because even though it's a small amount of radiation that's coming from that device, over time, your body tissue can be affected. So that's just something I do personally. There is some basis for believability when it comes to exposure to microwave energy, depending on how much it is and how powerful the antenna and so on. It's probably a good idea not to sit right next to your Wi-Fi router. And the important thing to understand about radio transmission, is that if you're using older versions of Wi-Fi, like G or B Wi-Fi, even N Wi-Fi 2.4, what happens is that when you cut the distance between the radio antenna and yourself in half, the strength of the radiation or radio signal quadruples. It's an inverse square law. So if you cut it in half again, and if you put it in your ear, that's pretty close, right? So cut it in half, cut it in half. The closer you move it to yourself, with every half distance change, the amount of strength of the radio signal, and it could be a microwave signal, the same thing used to cook food, increases by a factor of 4 every time the distance is cut in half. So if the Wi-Fi router is 3 feet away, and then you cut the distance in half to 1.5 feet, what you're experiencing by sitting a foot and a half from the Wi-Fi router is 4 times the strength of what it is when you're sitting 3 feet away. This is something I just thought would be good to mention. We'll talk more about this when we get into the physical layer and some of the. In our next module, we'll do a deep dive on radiation and electrolight and other frequencies of electromagnetic radio waves. Infrared is invisible light, but light is technically a radio wave. If you talk to physics folks, they'll explain, well, that's all part of the same spectrum, the electromagnetic spectrum. And radio waves are invisible, but visible light is what we see with our eyes. And it all depends on the frequency and that kind of thing. So again, we'll do a deep dive in the next module. The important thing that we want you to understand about this section of our study guide is the MAC address that allows the unique MAC address. It allows that interface to connect. So let's have a look inside here. If we go into our settings and we look at network and we look at Wi-Fi and we look inside this setting in particular, you'll notice that in most cases, the network address that's assigned to my laptop to talk to you now, and I'm sitting on 146.226.197.97 on the campus. That address is a public address by definition. The IP assignment is automatic, and it picked up that address by running a client program, which is operating as a service inside my running tasks and services. So if I go into my task manager and look, and then look down through here, I can find some things about DHCP. So the DHCP service is running when my network is active. And so it may not show in the first listing, but it's likely to show here. Everybody see this DHCP client?
Yeah.
Yep.
So so when I have an active network interface, the client service is running and it's waiting to connect. And the moment I connect and click in to connect to that Wi-Fi, it starts to broadcast with its MAC address. It says, hey, I need an IP address. And the client communicates to the DHCP server. In this case, at our campus, it's the same principle as what's in your Wi-Fi router, but it's much more sophisticated. And that's because there are many more clients on the campus that are connected. The thing to understand about MAC addresses is that they're 48 bits, but they're not 48 ones and zeros. Instead of having 6 octets, they have 6 pairs of hexadecimal values, and we're not going to worry about how to make sense of a hexadecimal value, except that one thing we mentioned Friday, each manufacturer gets its own group of MAC addresses to imprint or stamp or hard code into the wiring of that interface. So if I look up this particular MAC address, I can go onto the internet, and this is kind of fun to try, right? So you can look up free services to look up by vendor. You can tell who made your device, and if I paste this into there, I can paste my entire MAC address, right? Well, let's take my MAC address for the wireless device. I'm going to go back into here. Here is my physical MAC address for my wireless interface. Everybody see this?
Yeah.
Yep.
So I'm going to go ahead and copy this. Sometimes you have to put colons in place instead of dashes, but let's see what happens when we try to put this in here. Oh yeah, see, so the example is with colons. So what do I do to fix that? I've pasted it into a notepad. I'm going to go into edit and then use the replace feature, and I'll just replace the dash with the colon, right? Replace all. Everybody see what I just did there?
Yep.
Just made my life easy, right? Instead of having to, so if you type it in directly, you can make mistakes. I'm going to paste this in there and then search. And there should be something about my interface. Now my Wi-Fi component was manufactured by Intel. Okay. So even though I'm using an Asus laptop, the Wi-Fi component itself was created by Intel. So there you have it, right? Any questions about MAC addresses? So we have mentioned that the first thing that happens is a huge burst. When you connect your device to Wi-Fi, it's gonna blurt out, broadcast, hey, I need an IP address. Everybody sees that. Everybody on Wi-Fi, the thing you need to understand about Wi-Fi is that when you broadcast in Wi-Fi, every other connected device in that Wi-Fi network sees it, can read it. In this regard, Wi-Fi networks are much more exposed and vulnerable in terms of hacking than wired networks. And originally, wired networks were just as bad. Wired networks used a device called a hub, and we'll be getting into more of that in a bit. But so we'll explore and do a deep dive on network hubs as opposed to bridges, as opposed to repeaters, as opposed to routers, as opposed to switches, as opposed to layer 3 switches, as opposed to firewalls, and so on and so forth, right? So we're gonna learn about all the wonderful world of network equipment in the class, but the most basic of all is this wired hub. It was the way we connected wired computers together, and all it did was repeat everything that a device wanted to transmit to any other device, just to everybody. It was a multi-port repeater, essentially. And not long after that, everybody realized that's a really bad idea, because if somebody's plugged into your network, they can see everything that you're doing. So they came up with the idea of a switch. In simple terms, a switch isolates each port. We'll get into that more again. But the notion that Wi-Fi and Ethernet cable networks involve broadcast, we've talked about physical limitations, right? And when you're in that broadcast domain, you cannot have two IP addresses alike. And so it's good, it's very good to have smaller networks and better control over networks. But in general, when people are all broadcasting at the same time, you get a lot of interference. There are traffic collisions between the broadcasts. Now, in layman's terms, what's this like? I want you to imagine that all of you queue up. We don't have to imagine it. We can do this. All of you can unmute your mic and talk all at once. In fact, why don't we try that why don't we try that for just like 10 seconds? Is everybody willing to do that?
Sure.
Yeah.
Everybody unmute your mics. Everybody all at once unmute your mics. And then let's just talk. Let's just share something about ourselves, okay? Everybody. Yeah.
We're all just happy.
You know, I was driving. I was driving to.
You want to
I was. Oh my gosh! I was.
almost
It's almost like I can't make out what anybody's.
So what just happened there? I have a mute all button, thank God, because I'm like, okay, 10 seconds are up. The thing is that this is called contention. Another word for the collisions of broadcasts is called contention. So what are we saying? If you have enough devices on a gigabit Ethernet network and they're all talking at the same time, they're all transmitting at the same time, unless it's on a managed switch, right? You get this cacophony and you get a lot of collisions or contention with traffic. To put it bluntly, a gigabit network is not a full gigabit because everybody is like stepping on everybody. And that's a thing. And it's important to understand how that works. In fact, if a hacker wants to cripple a network, it's not hard to create all sorts of increasing loops of traffic that basically step on everything and everybody, and the contention becomes overwhelming and nobody can communicate. It's really important to have a protocol where people can identify who they want to talk to. And I know, and you know, if you go to a restaurant or you go to a party and you're talking at first, and there's a few people in the room. And then as guests arrive, the population in the room doubles, and it triples, and it quadruples. What happens to the volume level of the conversation?
I mean, it gradually increases, right?
It gradually increases to the point where it's hard to hear unless you're like right in somebody's face and you talk louder. Which of course does what when everybody else is talking louder now? Are things better or worse?
Worse.
Yeah, it's actually worse, right? So you see this in the physical world all the time. And this is something to understand with broadcast. We take it for granted, right? I want you to have a very clear idea that when we're talking about Wi-Fi, there is no way to isolate it for a given port. When you put it out on that radio, everybody sees it, everybody gets it, everybody can capture it and look at it. Which means it's important to make sure that certain things happen when you're on a Wi-Fi network that you might not worry about when you're at home. Things like whether you connect to a website and there's a padlock to encrypt what's happening between that website and you. Can everybody see this? That padlock is called TLS, Transport Layer Security, right? It's a certificate that's used to secure the communications to and from the website. Now, if you're on a website with this, on a Wi-Fi connection, and you start entering a password, you don't have to worry about people reading your password. But if you're on a website that doesn't have this, and you're entering a password, oh yeah, everybody sees your junk, including your password. So just thought I would mention that while we're talking about network applications.
I figured that's what that meant.
Yep. So if you get a warning that something is not encrypted and you're connected with Wi-Fi, you got to know if what you're on that website for is sensitive or important and whether or not you should enter information that's sensitive or important, because people will see it, right? Now, we will continue to basically circle back and take deeper dives and ever deeper dives on our Internet Protocol Network suite, right? From layer 1 all the way through layer 7. But what you need to understand is that when you have multiple layers, one of the benefits of having layers is that so long as manufacturers abide by the bottom 2 layers and they get the IP addressing correct, then they can interoperate with everyone else. So one of the cool things about network standards is that sometimes it's cool and a curse, is that they're not always standardized, meaning there are international standards that the IEEE and the IETF, the Internet Engineering Task Force, come up with. And in theory, manufacturers are supposed to comply by those standards. In practice, manufacturers cut corners all the time. And sometimes they have their own standard or protocol implementation, which can be terribly troublesome. In the wonderful world of smartphones, when you're dealing with cellular networking, the IMEI or SEID is the equivalent of a MAC address. It's the identity of that device on the cellular network. That's something I need you to know and understand. When it comes to cellular networks, it's not Wi-Fi, but they do have a similar thing, and it's called an IMEI or an SEID. Hexadecimal characters paired together, separated by colons. Sometimes not, but it's all just one string of characters. When you look at it, usually when you pull the battery, if you can remove the battery, or if you can look in the about section of your network device on iPhones and Androids, it'll tell you all of this. And it'll also give you the MAC address for the Wi-Fi interface, the Bluetooth interface, and so on, okay? Now, your own address at home. So when you're at home and you run ipconfig, we've done this already, you're going to get, in most cases, a private internal address, 192.168 something, and that's a class C, smaller private local address. And most routers will configure up to 253 connected devices. But my question to you is, you think that's good for your home network security? Should your home network be
think
open?
so.
Should your home network be open to 200 devices? What do you think?
No, because that's like for potential hacks can happen if your home's network is open to 200 devices. And also you have to consider about the broadband,
Yes,
like how much bandwidth and stuff like that. So if you're
Yeah.
running like 200 megabits internet speed and
Right.
you have 200 devices, you're probably only going to be running like 500 kilobytes out of 200 megabytes. Yeah.
Yeah, that's those are all good points, and you're correct. The thing to understand is that you have a private address, and then when you have something for the internet that needs to go out through your home network gateway, the gateway address is the IP address on the router, and it's usually 192.168.1.1 or .0.1. Then it's the packet of IP information is translated into a public address. So most home networks only have a single public address. What are we saying? Internet service providers need a public address to connect someone to the internet. When they set up internet service for your house, they need at least one. And the world ran out 5 years ago. So they're recycling public addresses. They work DHCP also, because if someone has a power outage and their router is dead for a time, when they come back up on the internet service provider's network, they could be reassigned a different IP address. So the public addresses are part of a pool that are recycled, and that's one way that internet service providers make do for the short term. Now, did we or did we not show you how to capture the output of some networking commands to a text file before? Is this something that we demonstrated? Yes or no?
You said, what did we demonstrate?
I was asking if we had demonstrated in class before these specific commands at the end of the study guide.
No, you went over some from the assignment.
Yes.
Yeah, you went over some of those, but I don't recall going
Right.
over the module one.
Well, let's do that now. So if you would do what I am doing right now, you can click on the start menu and you should type CMD. Just start typing CMD, and what you should see on your screen, can everybody see my screen now?
Yeah.
Yeah.
The pop-up, right? And can everybody see the run as administrator?
Yeah.
Okay, so some network commands will not run unless you have administrative privileges. It'll have a pop-up that says, hey, are you sure you want to do this? And you answer yes. And so here you have the administrator prompt. And when you're doing things in a CLI or command line interface environment, which is what the CMD environment is, it's a throwback to a previous operating system called MS-DOS. Some people call that a MS-DOS prompt or a command prompt. In Linux machines, it's called a terminal window. You can right-click the window up here, the title bar of the window, and you can usually go into properties, and then you can select different font sizes so that it's easier to read. And here I've selected yellow for the font color, right? So I go to screen text and I've selected yellow, and then for the font size, I've selected 24 instead of the default, just because I want you to see easier. And if you're, at sometimes we'll ask you to capture a screenshot rather than we'll ask you to capture a screenshot rather than the text file. In this case, though, you can highlight the entire contents of this. You can right-click it and copy it. And I just want to look at this in a text in Notepad just to make sure I don't have extra spaces, but I think that's proper. So sometimes when you're going from PDF into the command line, it's good to paste it into a notepad first to make sure that you don't have extra spaces, because an extra space can completely throw off the command. And for clarity purposes in the PDF, by the time it renders to the screen, there might be some extra spaces in there. In any case, what I wanted to tell you is that if you have the temp folder set up on your C drive, you would check in Windows or File Explorer. If you go to your computer where it says My Computer, or if your computer has a name, you can double click on the C drive and you should see a temp folder in there. If you do not have a temp folder, you can simply go to the white space on the right. You can use the right mouse button, not the left mouse button, but the right mouse button, and select New, and then Folder, and it'll start a new folder. You just give it the name temp, right? So I'm going to use the word other in this case, just because I already have a temp folder. Once I have a temp folder, if I go into that temp folder and I look at it, for clarity purposes, what I'm going to do is stuff all these extra files into, yeah, I'm going to stuff all these files into another subdirectory just to get them out of the way. And going back to my command, if I first paste this into a notepad to make sure it's right, and then I copy it, when I get inside my command environment, all I have to do is hit the right mouse button, and that's the same as pasting. So I'm going to go ahead and do that and then hit enter, and all of the output for this command is going to be captured into an ipconfig underscore result1.txt file. One advantage of this approach is if you have to repeat these things over time to capture different results, you can, get this window started and then just hit your up arrow key and then use the left arrow and then backspace and change this to a 2, right? And then hit enter. Now I have a different set of results from a different time in case your network connections change. That's handy. If I go into my temp folder now, right? And if I click on this, I'm in C:\temp. It's created a text file called ipconfig result1. And if I double click on this, it tells me what it's done is captured all of this stuff for posterity. I know the MAC address of my Ethernet interface, right? I have virtual machines on here, so I have extra Ethernet and extra adapters. But if I scroll down, I can find my wireless LAN adapter. Now, again, because I'm connected to the campus Wi-Fi, there is something about the Wi-Fi management networking device and the way that DHCP renews my lease. When you're assigned a temporary address by DHCP from a pool of addresses, it's leased for a certain amount of time. And this shows you that my lease was obtained on Monday, January 30th, 11:05 a.m. Notice when the lease expires. In some cases, the lease will expire days later. You can have DHCP leases in a home environment that go 7-8 days. But it's important to understand that on the campus, remember, we're using a pool of addresses that we recycle. So when someone's in a class for 90 minutes, when they finish the class, what do they do with their laptop? They park it and they turn it off and they stuff it in their laptop bag and away they go. So should that same address be reserved for my laptop until I come back on Wednesday? Probably not.
No, because you're not using the network.
That's right. So because I'm not using it, this is what DHCP does. It recycles these addresses, and that's an important thing to understand. The DHCP server on the Albert A. Sheen campus is located at the 244.7 address, right? So it's actually sitting on a different subnet, but we'll talk about why this magic actually works outside the network. This is the network address where the DHCP server is living, because that's a /24 subnet mask, right? So I'm looking at all three of these numbers. And yet I'm sitting on 197, right? So I'm sitting on 146.226.197, and I can still see and get an IP address from the DHCP server. I want you to notice that each network has its own gateway address. So when I'm sending this information to and from you, it's going through the gateway address that's typically assigned, right? It's one more than the network identity. So the network identity would be 146.226.197.0. The broadcast address would be 146.226.197.255. So I never use 255, but I can use 254. That's the highest number I can have in this network. And if we run out of enough addresses for enough clients, the DHCP server will actually assign a 254 address to someone instead of a 97 address. This gives you a pretty good idea how many people are active right now because of the short term of the lease. Any questions? So this command will show you something called a socket. It is a address port combination, and it'll show you which services are actually running on the PC. And that helps you determine whether or not your machine is the server or if it's connected to something out on the internet. It'll also show you the common resource or application that's running that service on the network. Now, when you do this one's really cool. It shows the connected networks, the neighbors on the network. So this one's also really cool. Between these two, you can figure out who's connected to what, and sometimes you catch some really nasty things happening. So I'm going to go ahead very quickly just to complete this, and then we have to close out our class. I'm going to go ahead and copy this. I'm going to put it in my notepad again to make sure I don't have any weirdness going on. I'll copy that again. Since there are no problems with spaces, I'll open up I'll use my right mouse button and hit enter, and this one will take a little bit to run. And in a minute, sometimes you have to hit enter again after a time. It's, there are cases where netstat gets a little stuck, and hitting enter can help sort of move it along. It usually takes a few seconds for netstat to complete running because it's scanning 65,536 ports that are open on your own machine, not on other people's machines, but on your own machine. While that's doing, you can open up another command prompt window just by doing this. So I can open this up or I can right click it and run as administrator. And now I have a second window up where I can paste in the, okay, so now I've got it finished. I've got a complete result from that netstat command. In here, I'm going to run the third one, which is netsh interface show neighbors, blah, blah, blah. I copy, paste that. Get into here, right click and hit enter. That one runs pretty quick. If I look at netsh, it's really cool. Okay, so this concludes our review of our module study guide. We will post the first version of your module 1 assessment. Please complete it before the start of class Wednesday. Okay. Any questions before we close out?